All right, guys, what we're going to do today is go over section 10.1, which is adding and subtracting polynomials. And to start, what we're going to do is go over some vocabulary. All right, so a polynomial is an expression in which the sum of the terms of the form ax to the k, where k is a non-negative integer. In other words, we're not going to have any negative exponents with us. Now, the degree of each term of the polynomial is the exponent of the variable. So say we had 2x cubed, the degree would be 3 because that's your exponent. Polynomials are usually written in standard form when they meet, which means the terms are placed in descending order from largest degree to smallest degree, or in other words, from largest exponent to smallest exponent. Now, the degree of the polynomial is the largest degree, or your largest exponent. And if I ask for the degree of a polynomial, I'm asking for the actual number. All right. Now, if I ask you to take a polynomial and classify it by degree, I'm asking for a word for the answer. Okay? And the words you need for that are given here. Okay, these are the words. If the degree is 0, you have a constant. If the degree is 1, it's linear. Degree is 2, it's quadratic. Degree is 3, it's cubic. And if the degree is 4, it's quartic. And you're going to have to memorize these. These are important for you guys to memorize. Really, you guys already know definitely constant, linear, and quadratic. It's not that hard of a stretch to do cubic and quartic. And again, polynomials can also be classified by number of terms. And if I ask you to classify, again, I want you to give me a word answer. For some reason, people just want to give me the number. I'm looking for the word. Okay? And if it has one term, it's a monomial. 2 terms, binomial. 3 terms, trinomial. You're going to have to memorize those words as well. If you get more than 3 terms, it's considered just a polynomial. So, let's take a little practice here. Let's look at this. If we complete this chart. In this first one, I'm just asking for the degree of the polynomial. So here I'm just asking for a word. We have -5. The degree of the polynomial is 0, right? It's a constant. It doesn't have any exponent. 1/4 x, the degree is just 1. Okay, -9x plus 2. On the x, the exponent is just 1, so there's your degree. X squared minus 6, the degree is 2. All right, opposite of x cubed plus 2x plus 1, the degree is 3, because that's your highest exponent. 3x to the 4th plus 2x cubed minus x squared plus 5x minus 8, the highest exponent is 4, so that's your degree. Now, if you classify by degree, okay, this is where when we say classify by degree, this is where I want the word. Okay, so here, -5, it doesn't have any variables, so this is a constant. All right, 1/4 x, degree is 1, so it's linear. -9x plus 2, again, the degree is 1, so it's linear. Okay, x squared minus 6, degree is 2, so that's quadratic. Okay, this next one, opposite of x cubed plus 2x plus 1, highest degree is 3, so this is cubic. Okay, and then highest degree here is 4, so this is going to be quartic. Okay, so these 2 columns here all have to do with the exponent and exponents. In fact, the largest exponent or largest degree. All right. If we classify by number of terms, it has really nothing to do with the exponents and everything to do with how many terms there are. And terms are separated by addition or subtraction. So this -5 is just one term, so it's monomial. And because I'm saying classify, that means that I want the word. 1/4 x just has one term, so again, monomial. Okay, negative 9x plus 2. Negative 9x is a term, 2 is a different term, so this is a binomial. All right, x squared minus 6. X squared is a term, it's really like negative 6 is a term. All right, so two terms, binomial. And then where we have opposite of x cubed, 2x, and 1, there's 3 terms. That's a trinomial. And then we've got 3x to the 4th is one term, 2x cubed, another term, negative x squared, plus 5x minus 8 or negative 8. There's 1, 2, 3, 4, 5 terms, so we would consider this a polynomial. All right. Now, if I ask you to identify the coefficients, all right, on an expression, okay, you're going to have to write the polynomial standard form and account for each degree, even if you must use a zero coefficient. So you're going to start with your largest degree. I look at this and I see my largest degree is this 2x cubed, so I'm going to start with that. Now, my next degree would be an x squared. I don't have that, so I got to show that with 0x squared. Okay, and then we have, or degree of 1 would be minus x, or that's just like plus a negative 1x. And then your constant is 4. So if I ask you to identify the coefficients, once you've got in standard form, you can do that. You've got your coefficients right here, and you have to include that 0. So you'd write your coefficients as 2, 0, negative 1, and 4. And that would be your answer as far as what your coefficients are. All right, guys, on the back of the page, we're going to go over quickly finding the sum and the difference of polynomials. We're just going to look at a couple different formats. One format is vertical format, and this isn't really anything super new for you guys because it's basically combining like terms. It's just a couple different ways to look at it. In vertical format, you really have to get stuff in standard form and then align like terms and columns. So, for example, we take this first polynomial, I have negative 8x cubed. I then put minus 9x squared plus x plus 2, getting standard form. Then I can take my second polynomial and line up the like terms. So I'd have 8x squared minus 2x plus 4. And the third polynomial, I'd start with the negative 9x cubed, again lining up like terms, plus 4x squared minus 1. Then when you add up the columns, you get negative 17x cubed plus 3x squared, because it'd be like, say, 12x minus 9x, minus x, and then 6 minus 1 would be plus 5. And there's your answer. To me, that seems more like more work. It's a way to do it, but then you have to rewrite the whole thing. You can see ahead of time, I just took this original problem and copied it down here, and you guys could do that really quick, but obviously you could start right with the problem. But horizontal format, what I like to do is I like to just go from highest degree down to your constants. So I like to pick out my highest degree in all these polynomials is 3, so I take negative 8x cubed and negative 9x cubed, and I get negative 17x cubed. Then I'd maybe look at my squared with my next degree, so we have minus 9x squared plus 8x plus 4x, or plus 8x squared and plus 4x squared. 8x squared and 4x squared, 12x, minus 9x, there's your plus 3x squared. Then looking at your x's, we have plus x and minus 2x is minus x. And then our constants, 2 plus 4 is 6, minus 1 is plus 5. So again, you really could do either. It's combining like terms. I tend to like horizontal format because it seems to be quicker. Because like, look at this next one. I can just start right off by, combining my like terms to starting with my highest degree. Like for example, I have 6x squared plus x squared is 7x squared. And then we have minus x minus 2x is minus 3x. And your constants, 3 minus 7 gives us minus 4. That to me just is really quicker doing that horizontal format than rewriting the problem all over again. Now, when you do differences though, you might want to rewrite because really you've got to take and think of the second polynomial as having a negative distributed in. You're subtracting this whole, oops, I gotta switch back to the pencil. We're subtracting this whole polynomial. So the first polynomial really stays the same. You got 6x cubed plus 5x minus 3. And it's like you're distributing a negative in the other one. So it's going to be minus 2x cubed minus 4x squared plus 3x minus 1. Then you can really do your horizontal format. We've got 6x cubed minus 2x cubed would be 4x cubed. And then x squared, well, there's only minus 4x squared, so there's nothing to combine that with. That stays the same. We've got 5x plus 3x gives us plus 8x. And then our constants, minus 3 and minus 1 gives us minus 4. So there's my answer. Again, whatever polynomial you're subtracting, you really got to distribute that minus into each term. First one's going to stay the same. We got 12x minus 8x squared plus 6, and then this would be plus 8x squared plus 3x minus 4. And then we can combine like terms. Now what works out nice here is we've got a minus 8x squared and a plus 8x squared. So the x squareds are really going to cancel. They're opposites, so they'll cancel each other. Then we have 12x plus 3x gives me 15x. And then plus 6 and minus 4 gives me plus 2. All right, so this section should have been kind of review, guys. Hopefully it'll help you with your homework.